All right, welcome back everybody. Today we are starting lesson 8.2. We are factoring with a numerical GCF. All right, so quick warm up, find the GCF of these two monomials. So let's start with 6. I want to list my factors of 6. I have 1 and 6 and 2 and 3. And if I look at 18, I have 1 and 18, 2 and 9, 3 and 6. I believe that is all of them. All right, now I'm going to expand out the variable part. So x squared y is x times y, and xz is x times z. So now let's look to see what do they have in common. Well, they both have a 6, so that's our numerical GCF. And they both have an x, so our GCF, is 6x. All right, let's do the same thing with 15. Those factors, I have 1 and 15, 3 and 5. For 40, I have 1 and 40, 2 and 20, 4 and 10, 5 and 8, and that is it. So now the variable part, x squared yz, is x times y times z. Xy squared z is x times y times z. So we're looking at the numerical GCF. I see that the biggest one they have in common is 5. And then what variables do they have in common? Well, here we have an x times y, and here we have an x times y. But we also have a z in both of them. So our GCF is 5xyz. All right, for this next set of problems, we are going to factor by finding the GCF. So I'm going to start a very similar way. So I have 5m cubed and 45. So what do they have in common? Well, the factors of 5m cubed are 1 and 5. I'm only looking at the number because 45 doesn't have a variable, so they can't have that in common. All right, so that's all my factors of 5. So 45, we have 1 and 45. We have 3 and 15. We have 5 and 9. I believe that is it. So if we want the largest factor, it's going to be 5. So 5 is our GCF. So I'm going to write that down. All right, so now we're going to start what's called factoring. So factoring is kind of like the opposite of distributing. So I'm going to take a 5 out, and I need to fill my parentheses. All right, so we can think of this like, imagine if you divided each term by 5. So 5m cubed divided by 5 equals m cubed. So that means an m cubed goes in there because I factored the 5 out. 45 divided by 5 equals 9. Since it's positive, it gets a plus 9. So this is my fully factored form. All right, the way we can check is by distributing it back in. So if I distribute, 5 times m cubed is 5m cubed, and 5 times 9 is still 45. So we get back right where we started. All right, so factoring is kind of, remember, just the opposite of distributing. So let's go to number 4. I see the numbers 3, 6, and 3. So it kind of jumps out that my GCF is 3, since they're all divisible by 3. All right, now since the last 3 doesn't have an x, I don't have to worry about taking an x out. So I know it's going to be 3 times something in parentheses. So if I do 3x squared divided by 3, the 3's cancel, I get x squared. So that goes in my parentheses. 6x, that was my next term. If I divide that by 3, 6 divided by 3 is 2, and I still have x, so positive 2x. And lastly, I have the 3, and if I factored out the 3, I can think of that like dividing. 3 divided by 3 is 1, so I have a plus 1. All right, don't forget that plus 1, even though you factored out the GCF. All right, so we have 3 times x squared plus 2x plus 1, and this is my fully factored form. All right, the next problem we have, number 5, I'm actually going to take out this negative. So it's a positive 6y squared minus 18y minus 24. So first, let's find the GCF. All right, so let's look at 6. Those factors, 1 and 6, 2 and 3. Let's look at 18. I have 1 and 18, 2 and 9, 3 and 6. Now let's look at 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So I have a y squared, a y, and no y's. So I can't take a y out. So my GCF is only going to be a number. And I see, a 6, a 6, and a 6. So my GCF is 6. All right, so this one we're going to do a little differently. All right, I could do 6y squared divided by 6. I could do negative 18y divided by 6, and I could do negative 24 divided by 6. All right, and that, whatever I get for those 3, that's what fills my parentheses. Or the other way to think of it is 6 times what would get me back to 6y squared? Well, I already have the 6, I'm just missing the y squared. So now when I multiply, 6 times y squared gets me back to 6y squared. All right, so next I want to get to negative 18y. So I know I'll need a y, and the other thing I know I'll need is a minus sign, because a positive 6, in order to get to a negative 18, needs to multiply by a negative number. So now 6 times what equals 18? Well, that's 3, so we have a minus 3y. And lastly, 6 times what gets us to negative 24? So positive 6 times a negative number will get us to negative 24. I don't know, 6 times 4 would give us that 24. Right, and if we had solved these problems on the right side, right, the 6 is canceled, giving us y squared. Negative 18 divided by 6 is negative 3 with the y left over, and negative 4, so you see we get the same 3 terms. All right, number 6. The GCF between 10a squared, negative 20a, and 35. So they don't all have variables, so I only am looking at the numbers. So 10, my factors are 1 and 10, 2 and 5. 20, I have 1 and 10, 1 and 20, 2 and 10, 4 and 5. And for 35, I have 1 and 35, 5 and 7. So my GCF, I can see, is going to be 5. So I will take a 5 out, and then I need to fill my parentheses. So what do I fill them with? Well, I started with 10a squared, and I factored out a 5, which is like dividing by 5. So 10 divided by 5 is 2, and I still have the a squared. Next, we have the negative 20a divided by 5, Negative 20 divided by 5 is negative 4, with the a left over. And 35 divided by 5 is 7, so we have a plus 7. And there is our fully factored form. And again, remember all of these we can check, we could redistribute, and we should get back to where we started. All right, continuing on, I'm going to skip the warm-up because we already did some. So now we are finding the GCF, but this time we have numbers and variables. All right, so first off, 12a to the 5th. I'm going to find all my factors of 12. 1 and 12, 2 and 6, 3 and 4. Now a to the 5th is a times a times a times a times a. All right, so if I want to look at my factors of 6a, 1 and 6, 2 and 3, and just a single a. So now what do they have in common? Well, they're both divisible by 6, so that's my numerical GCF. They both have a single a, so my GCF is 6a. All right, so 6a is what I'm factoring out. So I take out a 6a. What did I leave behind? Well, let's see, same process as before, 12a to the 5th. And if I factored out a 6a, that's like dividing by 6a. So 12 divided by 6 is 2. And then a to the 5th divided by a. If we remember our subtraction properties with exponents, we subtract, so 5 minus 1 gives us a to the 4th. Or when in doubt, expand it out, a times a times a times a times a on top over a on the bottom. 1 cancels on top and bottom, leaving us with 4. So 2a to the 4th. So that's my first filler. And the last one, 6a divided by 6a is just 1. So plus 1. And there is my factored form. So if we jump over to number 4, now I have y cubed, 6y squared, and 2y. So the y cubed doesn't have a coefficient, so I know my GCF is only going to be a variable. All right, the y cubed has 3 y's, y times y times y, 6y squared, 6 times y, and 2y is obviously 2 times y. So what do they have in common? Well, just a single y. All right, so when I take out a y, I started with y cubed, but I took one of them out, so that means I was left with just the 2, so that would be y squared. Now, with the 6y squared, I took out one of the y's, so drop that by 1 gives me 6y, or 6y to the first power. Then with the 2y, you can imagine take the 2 out or take the y out or divide by y, you're left with just the 2. So there's our fully factored form. And if you don't know what I'm talking about, y cubed divided by y, is y to the 3 minus 1 power, which is y squared. 6y squared divided by y, 6 times y to the 2 minus 1, which is 6y, and 2y over y, the y's cancel, giving us 2. All right, just a couple more. All right, number 5. Now we have a bunch of terms, 2x to the 4th plus 2x cubed minus 8x squared minus 4x. So none of these can be combined because all of our exponents are different. But I know that 2, 4, and 8 are all even. So that means they're all divisible by 2. So the GCF has to start with a 2. All right, I see the first term has 4 x's. The next term has 3, then 2, and then 1. So they all have at least one x. So I can take one out. I can't take more than one because that last 4x doesn't have more than one x. So I'm factoring out a 2x. So what does that leave behind? Well, if we've forgotten, we can always do 2x to the fourth divided by 2x. So the 2's cancel. 4x's on top, 1 on bottom leaves me just 3x's. So x cubed goes first. Then if I take 2x to the third and divide it by 2x, the 2's cancel again. 3x is on top with 1 on bottom, so 1 will cancel, leave me with 2, so plus x squared. Then if I have negative 8x squared divided by 2x, negative 8 divided by 2 is negative 4. X squared over x is just 1x, so minus 4x. Then if I have minus 4x divided by 2x, negative 4 divided by 2 is negative 2, and the x is on top, cancel with the x on bottom, leaving us with just negative 2. So here is our fully factored form. All right, and last one. 10n squared minus 20n to the fourth plus 35n to the sixth. So I know that all of these numbers end in a 0 or a 5, so they're all divisible by 5. And since 35 is not divisible by 10, I know that 5 is my GCF. All right, now n squared is n times n to the fourth is n times n times n times n to the sixth, n times n times n times n times n times n. So how many do they have in common? They each have an n times n. So along with that 5, I could say my GCF is 5n squared. So I'm taking out or factoring out a 5n squared. So what did I leave behind in parentheses? And again, reminder, factoring out is kind of like dividing. It's the opposite of distributing. So 10n squared divided by 5n squared. Well, the n squared over n squared will cancel. 10 divided by 5 is just 2. So let's move on to the negative 20 n to the fourth. I'm going to expand it out, so n times n times n times n over 5n squared. All right, so 2 n's on top cancel with 2 n's on bottom. Negative 20 divided by 5 is negative 4 with the n times n left over, so negative 4n squared. And lastly, I have 35n to the sixth over 5n squared. So 35 divided by 5 is 7. And I have 6 n's on top multiplying and 2 on bottom. So if I cancel 2 on top with the 2 on bottom, that leaves me n to the fourth on top. So plus 7n to the fourth. And there's my fully factored form.